The topic of my talk is about Metaverse. Um, I think in this morning's keynote, Arpit mentioned it, and probably you heard quite a bit of that. At least know that Metaverse is a new hot thing. I'm here trying to put some depth into it and see how that relate to open network and edge, and how we may think about it as a emerging technology as well as a new business opportunity. So that's what I would like to do. My co-presenter, Alex Clemm, unfortunately couldn't travel here. You see this is happening quite a bit, but I think he's online. Unfortunately, I checked with the meeting organizers here that he can't speak, so I'm going to talk on his behalf as well. Okay, so let's get started. A few words about myself. I'm the technology strategy lead in Futurewei, work on Metaverse, Web3, and trust. And relate to all those words, a lot of work is in Linux Foundation. I want to highlight a few that I got involved. And one of them is called Trust over IP, related to how do we have trust on the internet, as well as Web3 models, how could we make it work. The other is LF Edge. I'm in the board of that open source project. A lot of wonderful work going on there. And then the last one probably is W3C, which is standardizing the next generation of web technology. And a lot of the terms I probably will mention as well. And Alex, he's a distinguished engineer in Futurewei and focus on future networks. So a lot of the, I think, exciting things like the future network, we use 6G or future G, right? What really is in there that is really essential for Metaverse. So I'm trying to cover that on behalf of Alex. And so there are a lot of further reading materials, etc. That we'll be happy to share on the schedule site as well. So what is Metaverse? And I think this as this first slide about Metaverse. It's going to continue for quite a while. So there's no definition, and I'm sure all of you in your head have a definition. And that's not bad, not wrong at all. So one way to look at it, I like the John Rocchitero from Unity. He defines as always real time. I think that's a keyword. I like that. Often 3D, often interactive, often social, and persistent. And so those are sort of optional, but most of us still think that way. And the other definition that you will hear a lot as well is the word immersive. And that's the feeling of it. It's really a very personal thing. So the easy sort of analogy we have is, our meeting here, in person and immersive. We get real time, everything is cool. You go to a Zoom meeting, pretty nice, but you don't get that very immersive feeling of it. So you don't see people's gestures very well. You don't get the impression or a lot of other information, ambient information you want to get, right? And so what we can think of is like, do you have a version like one day we could have remote attendees that feel as if they are present here, right? And what exactly mean, it's really very hard to determine. But as we dive deeper, I think you get a feeling of what those really mean. The other slide, I think it's important to look from technology side. Metaverse is I would say is a vision about the future of the internet. That's the best way to think about it. Includes everything. So these are many dimensions, and they are not even complete, even for technology. In addition to economics, into social aspects. So it's a much two impact to what we are thinking about. But for today's talk, I'm going to focus on the marked two areas. One is edge and cloud, and the other is network. So we think Metaverse as a mega trend. So as a mega trend, it's going to take a long time to develop. So what we see today, feel today, may not be what the real thing is going to be, right? And so it's important to keep that in mind. It's also a huge opportunity. So these are the quote 3 analyst report on what those are. And all of them are in trillions of dollars. In fact, the one sponsored by Meta or Facebook actually is the lowest one. But there are multiple of trillions of dollars. So that's the large, I think, a cycle of the next technology wave. We'll probably spend some time on this particular picture a little bit, so to lay the background of what are the critical roles of open network and edge going to play. So in this picture, the center is a depiction of a 3D model and a emulation or simulation of reality. Okay, so imagine some creator either created virtually, so like in a game situation. In this picture, we are doing digital twins. So there's a chemical plant, quite complex. There's a digital version of that. That's the modeling, right? So digital twins, you may have sensors to do that, automation, but you can also create them from your design draft, etc. And then we have 3 persons. They are physically, remote, and they remotely present. They present in the virtual space, and each of them need a network, and the network will require also to be able to sort of incorporate their local environment, which is your surroundings. So that could be, an office shown in the lower corner, but also, headsets and other ways you can do it, or glasses, or a surrounding environment, right? So all those need to be remotely present and simulated there. So you can see the interaction are quite complex, and they require intensive processing as well as intensive networking. I'm going to talk about now jump into the opportunity for network provider, or what network can do. So the first thing what these will do is that the opportunity comes down to a few aspects. One is another application with lots of traffic, so that's good. But in the past, when this kind of thing happened, we see most of the value, or people, the money flows up rather than stay in the network. So that's a challenge we need to think about. How do we resolve that? The second one is the question of, we've always been playing the model of like internet as the best effort service, and that's still working pretty well. But for Metaverse, is that sufficient, right? Does the network require additional services to go beyond the best efforts? And so the examples of these we can think of as a real-time requirement. So these are the, whether it's twins or digital models. The other one is any kind of control, so haptic control in AR space. Any kind of operational things that we want to do through that model to the real chemical plant, that would be require much stronger network support. And then, it's just the massive amount of data volume and computation required for holographic or photorealistic avatars and landscapes. So those all introduce the need for more bandwidth and lower latency. The first one that a lot of work being done is about the high precision services. So how do we go from low to actually quantify or guaranteed latency? How do we go from best effort to guaranteed one? So those changes, I think the guarantees creates commercial value. So not only that you are able to say, well, I'm going to support your application pretty good, but I want to provide a guarantee to you that's additional value that customers or consumers are willing to pay for it. So that's very important, and that point out the requirement of high precision services. In order to do that, we have two levels of challenge, both technical side and business side. So the technical side, these are hard problems. We've been working on these kind of set problems since the inception of the internet itself. And we will go through some of the examples what we can do in that area. But both the protocols and technology, but also deployment and operation. You can imagine the system would be highly automated because any reaction that require operational, not only human interaction, but also like just the operational systems we design today, like management, for example, that goes through multiple layers of interaction. In order to make a decision, those will be very hard to achieve for the latency we are looking for. The other one is a business challenge. If we invest this kind of technology, it's going to be very costly. And how do we actually position our operators so that there is a good return on these investments in? So to address high-level technical challenges, I want to just point to some of the work that we've been doing and the community and standards are working on. So the first example is on the lower layer. It's called IEEE TSN. That's a networking service. How do we get high throughput and low latency? The other one is in IETF called DetNet and deterministic networking. And so the two, it's like a layer 2 and layer 3 combined together gives us a lot of potential means to actually technically solve the problem. The other side is looking at the business challenges. How do we create a value, and the value can be recognized commercially, right? And a big, I think, thing that our technical solution can help is accounting. So this is really to say, how do we know for sure that these accuracies, coverage, and your performance guarantees are actually met? So very precise accounting is a very important topic. Things we cannot measure, we cannot do it in some way. And so that is a very good, I think, a challenge that we need to solve in order to realize the business opportunity there. So on the accounting side, what's really important, I think the keyword in the last speaker also mentioned is SLO, the service level objectives, and SLI, which is in accounting, right? So these are metrics that were very important when that is out of bound. How do we know them? How do we control them? And how do we actually be able to network the automated algorithm to prevent these things? So hopefully that gives you some highlight of the networking sort of challenges and we see as the core components that can make the networking work for support for Metaverse, but also increase the value of the network. The next, I'm going to switch to Edge. So the picture here is showing a vanilla way of solving the Metaverse problem from imagine we are in a model, I turn, and that turning can happen really quick. And the entire view in front of me need to be recalculated in that way, right? And so that's the latency. If you look at the loop, it's what's going to happen. Now, this loop is actually quite idealized. It means the network's working perfectly, and it's pretty close to my home, right? But even that is about 70 milliseconds of delay, both for computing and transmission delays. With AI predictions, motion predictions, they can reduce that perception of the delay to about 8 milliseconds. So that's a huge importance of like the computation has to come in. Network alone cannot solve the problem. And so they're always real time, interact, immersive. All these cannot be purely finished, supported by networking alone, because networking slows reduce the delay, but cannot remove the propagation delay, right? The speed of light delay is still there. And to do that, we need to move something. The computation need to move much closer to the person. And so in some way, we can say this is the old cache, right? But I think very important to recognize it's not a simple cache. It's going to be very compute intensive and intelligent cache. So that gives us to think about the edge or the edge of the cloud in a very different light, because now the cloud is getting intelligent. It's going to have very personal perspective and value. The other way to look at this, we all know that we need to have AI to do all this, because that the motion prediction has to happen. And prediction or AI algorithms do this statically works pretty well. Unfortunately, to deploy in this scale, it has to be better than what we are doing today. Today, we just pull all the data, everything into cloud and do calculation and then come back, right? So that delay is way too high. Plus, the privacy issues are humongous. Because imagine what kind of data you are sharing. You're literally millisecond by millisecond sharing data about how your eye is dilating, everything, right? So that cannot happen. So there is a mechanism that can be, we can do machine learning, but without these downside. And overall framework is called federated machine learning. And I provide some, but we won't be able to dive deep into it. But these basically give us, I think about a way of like deploying these kind of machine learning algorithms on the edge, so that you have a better protection and better performance as well. The other example I want to also share in the Web3 space is about persistent decentralized storage. So here in the example is something called Interplanetary File System, IPFS. If you haven't heard of it, I strongly recommend. It's very interesting, very good technology. This creates a quantum-based addressing system for big files. So if you think about the digital asset, I need to do that rendering, right? The asset needs to sit somewhere, and you don't want that to be sitting on someone's private data center. It's not only too far, but it's also not very private. And so these IPFS allow you to actually be able to do content addressing, so you don't tie to any particular location. They can be propagated in any way, completely separately from the working of the network itself. So these systems, I think, also give value to the edge. The edge is a perfect place to be this decentralized storage. Okay, so I'm looking at my time. I want to leave some time for questions. So I want to give you a few key takeaways on this. The first one is about open network and why we think that the future of networking is very bright. Metaverse will create this new wave of interest and investment and value for networks. So these, I think, shows that not only more demand for higher throughput, but also tightly bounded latency. And to do that, we need to create a new generation of network architecture and primitives available for applications to make use of these networking features. And so that we were not only working to support the metaverse, but also increase the value of the network in the ecosystem. So that's the first takeaway. The second one is that the edge will become indispensable part of the infrastructure. And so it's no longer just a optimization of the cloud, right? So edge becomes, I say, intelligent and personal. And so they have very high business values. It's intelligent because you're going to need the main computation actually going to happen here in your personal perspective. And you basically push off the slower batch mode computation to the cloud, but the edge plays a very, very active role. Also, the edge is your personal thing, right? It's like your cloud, but it's more personalized. So I think that consumers and the end users in enterprise and other industries will have a strong interest in how the edge works. And that creates, I think, a very high business value for edge computing as well. And the computer have a delay. Come on. Okay. And so the third one, I think, is like to think about beyond what we be working on day to day on networking and edge. But I think the vision of Metaverse, while the vision is still changing, but the vision itself give, I think, us the optimistic view that the coming decade is going to be a golden age for network and edge computing. Very similar to like the 90s and early 2000s when we have the first wave of internet becoming available and all of a sudden new applications unlocked, right? This feels like the same way because our investment is going to be huge. We have to change the fundamental best effort internet into a assured service and intelligent internet. And that, I think, once that first round of technology investments done, will unlock a new wave of applications that's very high value. And so I think I want to probably quote what the keynotes saying, don't miss this wave, right? I think it's at least a decade for the vision to become quite clear how that will look like, and the basic building blocks being invented and deployed. But this is a great time, I think, to know Metaverse and to also be starting to think about the kind of technology and products that are going to be needed to realize this vision. So that's my talk, and my computer's acting weird in looking in. Okay, here you go. So I just want to leave this slide on. We have a related session this afternoon, 2 o'clock, Cloud and Metaverse. I will be present there again, more related to standards and open source projects. But for this talk, I want to just stay on the topic of network and edge computing. And I think we have some time for questions and maybe share your thoughts. Yes.
Thanks for your presentation. Very illuminating. I was curious about your thoughts on the requirements for networking in terms of computation and communications. Like what kind of throughputs? Obviously, it will vary from use case to use case. But say in the next 2 years, what are the dominant throughput and latency requirements that operators should think about? And then going further into the decade, what are we trying to achieve in terms of requirements?
Sure, yeah. There are a lot of ways people can estimate the requirements. So if we like imagine a room, like pick a simple scenario you can estimate. But for photorealistic virtual reality or augmented reality, right? The type of communication happen it's both ways. So we talked about downstream. Most of the time today we consume static media, right? The movies are huge, but we are only going in one direction. But in the metaverse, it's both directions. So we have a fundamental problem because the upstream, the networks are not built for the upstream, right? And so that need to be solved. And the type of requirement, the number goes quite high. If we are purely counting like what that is going to be, each one will be similar to what your movie look like, except this time it's real time. So you need to calculate, or you can make, in a way, you are making the movie as you're moving, right? It's actually the same algorithm. So we use some of the software and specs coming from the movie industry. So the models, for example, how do I express something? How do I express the lighting, the tone of the color, all that thing is exactly, you probably heard about this Academy Software Foundation within Linux Foundation too. And they are speccing those out, there's software code for that. So we are basically making a live kind of a documentary, right? And you are streaming it to cloud or whatever that the virtual model lives. And that need to be synthesized together in real life, and then downstream back to you. And so you can imagine, a naive implementation, these bandwidths are humongous. Maybe the network in 6G will solve some of these problems. I think bandwidth is relatively easier to solve. The latency is much harder, because latency requires us to also rethink the architecture of it, and where this computation happens. It's not easy, right? It's easy to sort of like just offloading a little bit, do little caching without changing the architecture. But if we want to change the architecture, which I think we're going to have to do, then it's a major change and major upgrade for the entire internet. Sorry, any other questions, comments? Yeah, when do we? Well, some people say you already seen it, right? A good example people come up is the Second Life. Yeah. The other aspects people come up with would be a lot of the games people already play. Those are, I think, it's good to understand them because they are the first ones to be interacting. Not only how to construct them, what are the problems. They're not the final form, naturally, but I think they give us a good indication where those need to be. Education, for example, has been doing quite a bit. So these massive educations, or even Zoom, right? So I'm waiting to see Meta and Zoom. They announced they're going to make your virtual presence so you can do Zoom meetings. But today it's not immersive. So today, when you go, with a headset to go attend a remote meeting inside the so-called metaverse, you are not immersive into it. You actually see a flat screen because the 3D version is not there yet. The 3D version requires modeling of not only the virtual meeting room, which is relatively easy to do. You only have one. But if you have 1,000 attendees, each person needs to be virtually rendered as well, and that we just don't have that kind of systems that can experience now. In the lab, you can. So I think the new headsets coming out, some of them are in thousands of dollars nowadays, but those headsets have the capability to achieve all of this. It's just they're not scaled up yet to the scale we're talking about over the internet. So that's where we are. It's an exciting time, and I thank you for coming to this talk and appreciate all the feedback. Thank you.